Welcome. We're going to be working on Chapter 5, Lesson 2. We're going to be talking about polynomials. So what we're going to learn in this lesson is how to add and subtract polynomials, how to multiply polynomials. And so some of the vocabulary words to keep in mind are what is a polynomial, what are terms, what are like terms, what's a trinomial, what's a binomial, and what is the FOIL method. So how can polynomials be applied to financial situations? So a certain student wants to attend Purdue University in Indiana, where the out-of-state tuition is $13,872. Suppose the tuition increases at a rate of 4% per year. You can use polynomials to represent the increasing tuition costs. So here you can see year 1, that's the tuition, year 2, that's the tuition, year 3, that's tuition, year 4. And so you can see that it kind of goes up at a certain rate. So let's look at this. It says adding and subtracting polynomials. If R represents the rate of increase of tuition, then the tuition for the second year will be the original tuition times 1 plus the rate. For the third year, it will be the original tuition times 1 plus the rate squared, or 13,872 R squared plus 27,744 R plus 13,872, which is just this written in expanded form. This expression is called a polynomial. This expression right here is called a polynomial. A polynomial is a monomial or sum of monomials. So if you notice, this is a monomial, this is a monomial, and this is a monomial. So the sum of these monomials is considered a polynomial. So the monomials that make up a polynomial are called terms of the polynomial. So in the polynomials such as x squared plus 2x plus x plus 1, right, you have 1, 2, 3, 4 monomials being added together. Each one is considered a term, each monomial. So the two monomials, 2x and x, though, since they both have the same variable with the same exponent, those are what are considered like terms, all right? So since these are like terms, I can actually combine them. So the result would be x squared plus 3x plus 1, because you could add the 2x and the 1x to make 3x. The polynomial x squared plus 3x plus 1 is what's considered a trinomial because it has 3 unlike terms. It's got 1, 2, 3 terms, right? 3 monomials being added together. A polynomial such as xy plus z cubed is a binomial because it has 2 unlike terms. The degree of a polynomial is the degree of the monomial with the greatest degree. For example, if I had x squared plus 3x plus 1, the degree of this polynomial would be 2 because out of the 3 terms, this has the highest degree, which is 2. In this one, xy plus z cubed, the degree of this polynomial would be 3 because the degree of this monomial is 2, right? 1 and 1 would make 2. And this one has an exponent of 3, so this would have a 1 of 3. So between the two terms, this term has the highest degree, so that means the whole polynomial has a degree of 3. So just something to keep in mind is the prefix bi means 2, and the prefix tri means 3. So let's try to identify some degrees of a polynomial. So it says determine whether each expression is a polynomial. If it is a polynomial, state the degree of the polynomial. So here we have 1/6 x cubed y to the 5th minus 9x to the 4th. So first we have to determine if it's a polynomial. Well, the expression is a polynomial because each term is a monomial. So this is a monomial and this is a monomial. So it's just a difference of those two monomials, which is considered a polynomial. So the degree would be, well, let's first identify the terms here. So the first term has a degree of 8 because 3 plus 5 is 8. And the degree of the second term is 4. So that means the highest degree is 8. So that means the degree of the polynomial is 8. So degree of 8, degree of 4, you take the highest one, which is 8. And then let's take a look at b here. So b would be x plus the square root of x plus 5. So this one would not be considered a polynomial because this right here is not a monomial. Remember, a monomial cannot have a variable under a radical. So technically, since this is not a monomial here, x is a monomial, 5 is a monomial, but since the square root of x is not a monomial, then the whole thing is not considered a polynomial. To simplify a polynomial means to perform the operations indicated in combined like terms. So let's go ahead and take a look at an example. So here it says simplify 3x squared minus 2x plus 3 minus x squared plus 4x minus 2. So if I take my original expression here, if I'm subtracting everything in this parentheses here, I can distribute this negative sign, right? So I can make it look like negative x squared minus 4x, and then I have two negatives here, so negative 2 is positive 2. So basically I distributed this negative sign here, and that's what gives me this expression. So now I can take a look at this and look at some like terms. So here I have 3x squared minus 1x squared. Those are like terms. I have minus 2x minus 4x. Those are like terms. I have plus 3 and plus 2. Those are like terms. So if I combine the like terms, that'll allow me to simplify this. So 3x squared minus 1x squared is 2x squared. Minus 2x minus 4x is minus 6x. And positive 3 plus 2 is 5. So this would be the simplified answer. From multiplying polynomials, you can use a distributive property to multiply polynomials. So here they want us to multiply and simplify. So here again, we'll use the distributive property. So 2x times everything in this parentheses, right? So I'm just going to distribute the 2x. So 2x times 7x squared, 2x times negative 3x, 2x times 5. So when I multiply these out, 2x times 7x squared, well, 2 times 7 is 14, and x times x squared is x to the third. 2x times negative 3x, well, 2 times negative 3 is negative 6, and x times x is x squared. And then 2x times 5 is 10x. So in example 4, that FOIL method, the example 4 is the one we're going to look at next. We're going to use what's called the FOIL method, and it's used to multiply binomials, or actually polynomials more specifically. The FOIL method is an application of the distributive property that makes multiplication a lot easier. So the FOIL method is just the product of two binomials is a sum of the products of the first terms, the outside terms, the inside terms, and the last terms. So let's look at an example of this. If you were asked to multiply these two binomials together, right, 3y plus 2 times 5y plus 4, using the FOIL method, right, I would take 3y times 5y, the first terms, 3y times 4, the outside terms, 2 times 5y, the inside terms, and then 2 times 4, the last terms, right, the last terms in each one of the binomials. It would look like this, right? My first term is multiplied, my outside term is multiplied, my inside term is multiplied, and my last term is multiplied. And really, that's all you're doing is you're kind of doing this kind of rainbow method where I'm multiplying the 3y times the two things in the second parentheses. Then I'm multiplying the 2 times the second things in the parentheses. And then once I do that, 3y times 5y is 15y squared. 3y times 4y is 12y. And then 2y times 5y is 10y. And then so 12 plus 10 is 22y, right? And then 2 times 4 is 8. So this allows me to simplify a problem like this. So let's look at one more example. So if I was asked to multiply polynomials, so here I have something with 3 terms, right? That's a trinomial times a binomial. You can still use the same strategy, right? So I have n squared times n squared times 4, and then 6n times n, 6n times 4, and then negative 2 times n and negative 2 times 4. So it would look like this. So basically I'm taking each term and then multiplying it with everything in that second parentheses. So now I can kind of use a distributive property here. So n squared times n, and then n squared times 4, 6n times n, 6n times 4, negative 2 times n, negative 2 times 4. And then it just comes down to simplifying. N squared times n is n to the third, n squared times 4 is 4n squared, 6n times n is 6n squared, and 6n times 4 is 24n, negative 2 times n is negative 2n, and then negative 2 times 4 is negative 8. And then now we have to combine like terms. So here I have my n squareds, 4n squared, 6n squared, those can be combined to 10n squared. 24n minus 2n, those are like terms, so that would become plus 22n. So this would be my final answer here. So now it just comes to using the distributive property and combining like terms. Thank you guys for watching. Let me know if you guys have any questions.